All right, starting out the new year, and I wanted to go ahead and relearn Java. So, I think this would be helpful to new students and old. Um, it's I will do my best to post as many videos as possible. Um, so this book is the Introduction to Java Programming and Data Structures. It's the comprehensive version by Y. Daniel Liang, Pearson edition, the 11th edition. So I'm going to read throughout the whole book, every chapter that is available, chapters 1 through 30, if I'm not mistaken. Yep, that's all pretty neat stuff. Those who have the ability that, you read, but you don't really know what you're reading, like you need someone to go ahead and actually read to you to understand that type of comprehensive. This will be very helpful for you, and along the ways, I will also probably break through and, I don't know, see something random. So, nothing is edited. Everything is just the way I'm doing it. So, first chapter is 1.1 Introduction. And also, sorry about the background noise of my parakeets. The central theme of this book is to learn how to solve problems by writing a program. This book is about programming. So, what is programming? The term programming means to create or develop software, which is also called a program. In basic terms, software contains instructions that tell a computer or computerized device what to do. Software is all around you, even in devices you might not think would need it. Of course, you expect to find and use software on a personal computer, but software also plays a role in running airplanes, cars, cell phones, and even toasters. On a personal computer, you use word processors to write documents, web browsers to explore the internet, and email programs to send and receive messages. These programs are all examples of software. Software developers create software with the help of powerful tools called programming languages. This book teaches you how to create programs by using the Java programming language. There are many programming languages, some of which are decades old. Each language was invented for a specific purpose, to build on the strength of previous languages. For example, or to give the programmer a new and unique set of tools. Knowing there are so many programming languages available, it would be natural for you to wonder which one is best. However, in truth, there is no best language. Each one has its own strengths and weaknesses. Experienced programmers know one language might work well in some situations, whereas a different language may be more appropriate in other situations. For this reason, seasoned programmers try to master as many different programming languages as they can, giving them access to a vast arsenal of software development tools. If you learn to program using one language, you should find it easy to pick up other languages. The key is to learn how to solve problems using a programming approach. That is the main theme of this book. You are about to begin an exciting journey learning how to program. At the outset, it is helpful to review computer basics, programs, and operating systems, OS. If you are already familiar with such terms and central processing unit, CPU, memory disks, operating systems, and operating languages, you may skip section 1.2 to 1.4. You can go ahead and skip this if you already know about it, but I will be reading right through it as fast as I can. This will probably take 2 videos to do, just letting you know. Now, going forward. Section 1. 1.2, what is a computer? A computer is an electronic device that stores a process data. A computer includes both hardware and software. In general, hardware comprises the visible physical elements of a computer, and software provides the invisible instructions that control the hardware and make it perform specific tasks. Knowing computer hardware isn't essential. Programs instructions have on the computer and its components. This section introduces computer hardware components and their functions. A computer consists of the following major hardware components. See figure 1.1. And so it says a central processing unit, which is the CPU, memory, main memory, storage devices such as disks and CDs, input devices such as the mouse and the keyboard, output devices such as monitors and printers, communication devices such as modems and network interface cards, and IC. A computer's components are interconnected by a subsystem called a bus. You can think of a bus as a sort of system of roads running among the computer's components. Data and power travel along the bus from one part of the computer to another. In personal computers, the bus is built into the computer's motherboard, which is a circuit case that connects all of the parts of a computer together. And so a bus, I'm going to go ahead and show you guys what a bus is. The battery's pretty low on my phone. But anyways, so the figure shows the bus, storage device, memory, CPU, communication devices, input devices, output devices, etc. Alrighty, so that was the figure. So now 1.2.1, Central Processing Unit. The Central Processing Unit, CPU, is the computer's brain. It retrieves instructions from the memory and executes them. The CPU usually has two components, a control unit and an arithmetic logic unit. The control unit controls and coordinates the actions of the other components. The arithmetic logic unit performs numeric operations such as addition, subtraction, multiplication, and division, and logical operations, comparisons. Today's CPU are built on small silicon semiconductor chips that contain millions of tiny electric switches called transistors. For processing information, every computer has an internal clock that emits electric pulses at a constant rate. These pulses are used to control and synchronize the pace of operations. A higher clock speed enables more instructions to be executed in a given period of a time. The unit of measurement of clock speed in the hertz, with 1 hertz equaling 1 pulse per second. In the 1990s, computers measured clock speed in megahertz, MHz, but CPU speed has been improving continuously. The clock speed of a computer is now usually stated in gigahertz, GHz. Intel's newest processors run at about 3 gigahertz. CPUs were originally developed with only one core. The core is the part of the processor that performs the reading and executing of instructions. In order to increase the CPU processing power, chip manufacturers are now producing CPUs that contain multiple cores. A multi-core CPU is a single component with 2 or more independent cores. Today's consumer computers typically have 2, 3, or even 4 separate cores. Soon, CPUs with dozens or even hundreds of cores will be affordable. Section 1.2.2, Bits and Bytes. Before we discuss memory, let's look at how information, data, and programs are stored in a computer. A computer is really nothing more than a series of switches. Each switch exits in two states. It says each switch exists in two states, on or off. Storing information in a computer is simply a matter of setting a sequence of switches on or off. If the switch is on, its value is 1. If the switch is off, its value is 0. There's zeros and ones are interpreted as digits in the binary number system, and are all called bits, binary digits. The minimum storage unit in a computer is a byte. A byte is composed of 8 bits. A small number, such as the number 3, can be stored as a single byte. To store a number that cannot fit into a single byte, the computer uses several bytes. Data of various kinds, such as numbers and characters, are encoded as a series of bytes. As a programmer, you don't need to worry about the encoding and decoding of data, which the computer system performs automatically. Based on the encoding scene, an encoding scene is a set of rules that govern how a computer translates characters and numbers into data with which the computer can actually work. Most scenes translate each character into a predetermined string of bits. In the popular ASCII encoding scene, for example, the letter capital C is represented as 01000011 in 1 byte. A computer's storage capacity is measured in bytes and multiples of the byte as follows. A kilobyte, KB, is about 1,000 bytes. A megabyte, MB, is about 1 million bytes. 1 gigabyte, GB, is about 1 billion bytes. A terabyte, TB, is about 1 trillion bytes. A typical one-page Word document might take 20 kilobytes. Therefore, 1 megabyte can store 50 pages of documents, and 1 gigabyte can store 50,000 pages of documents. A typical 2-hour high-resolution movie might take 8 gigabytes, so it would require 160 gigabytes to store 20 movies. Section 1.2.3. Memory. A computer's memory consists of an ordered sequence of bytes for storing programs as well as data with which the program is working. You can think of memory as the computer's work area for executing a program. A program and its data must be moved into the computer's memory before they can be executed by the CPU. Every byte in the memory has a unique address. As shown in Figure 1.2, the address is used to locate the byte for storing and retrieving the data. Since the bytes in the memory can be accessed in any order, the memory is also referred to as random access memory, which we all know as RAM. Alright, so I will go ahead and show you the figure that it's talking about. Memory address, memory content. So here's your address, and this is their how the character is represented, basically. So this literally stands for capital C and so on, little r, And as we'll learn throughout the book, there's more information on the actual letters. At least that's what I remember. Alrighty, so that just shows the memory stores data and program instructions in unique addresses memory locations. So today's personal computers usually have at least 4 gigabytes of RAM, but they're more commonly have 6 to 8 gigabytes installed. Generally speaking, the more RAM a computer has, the faster it can operate, but there are limits to this simple rule of thumb. A memory byte is never empty, but its initial content may be meaningless to your program. The current content of a memory byte is lost whenever new information is placed in it, like the CPU. Memory is built in silicon semiconductor chips that have millions of transistors embedded on their surface. Compared to CPU chips, memory chips are less complicated, slower, and less expensive. Section 1.2.4 Storage Devices. A computer's memory, RAM, is a volatile form of data storage. Any information that has been saved in memory is lost when the system's power is turned off. Programs and data are permanently stored in storage devices and are moved when the computer actually uses them to memory, which operates at much faster speeds than permanent storage devices can. There are 3 main types of storage devices: magnetic disk drives, optical disk drives, CD and DVD, universal serial bus, which stands for USB, flash drives. Drives are devices for operating a medium, such as disks and CDs. A storage medium, physical stores data and program instructions. The drive reads data from the medium and writes data onto the medium. Disks. A computer usually has at least one hard drive. Hard disks are used to permanently storing data and programs. Newer computers have hard disks that can store from 500 gigabytes to 1 terabyte of data. Hard disk drives are usually encased inside the computer, but removable hard disks are also available. CDs and DVDs. CD stands for compact disc. There are 3 types of CDs: CD-ROM, CD-R, and CD-RW. A CD-ROM is pre-pressed disc. It was popular for distributing software, music, and video. Software, music, and video are now increasingly distributed on the internet without using CDs. A CD-R, which stands for CD recordable, is a write-once medium. It can be used to record data once and read any number of times. A CD-RW, on the other hand, is a CD that is rewritable. Can be used like a hard disk, that is,